Hello everyone. So in this video I'll be discussing with you about motion. This is from class 9 physics portion, chapter 8. So going on straight to the main topic, let us see what is the meaning of motion. Motion, a body is said to be in motion if it changes its position, or if it is moving, then we call it as a motion. Opposite to motion, we call it rest or stationary, which means if the body does not change its position with time, then we call, or we can say, the body is at rest or stationary. Then there are two types of quantity. Okay, one is scalar quantity, another one is called vector quantity. Okay, scalar quantity means all those physical quantities which depend only upon magnitude. Magnitude means the value, all right, and vector quantity means all those physical quantities which depend both on magnitude as well as direction. So physical quantities like distance, time, acceleration, velocity, force, work, pressure, current, okay, all those are the physical quantities. Then there are two types of motion that we can discuss about. One is called uniform motion, the other one is called the non-uniform motion. Uniform motion means if a body covers equal distance in equal interval of time, then we call it as a uniform motion. Non-uniform motion means if a body does not cover equal distance in equal interval of time, then we call it as non-uniform motion. Okay, so what we have discussed is uniform, okay, and non-uniform. Okay, now let us go to distance and displacement. Okay, so about distance. Distance is the total part covered by a body. Okay, so the total part covered by a body is called distance. The SI unit of distance is meter and it is a scalar quantity. Okay, then the other one is displacement. Displacement is a measure of straight line. Okay, it measures in a straight line between the initial position and final position of the object or body. Okay, so we only measure in straight line from initial point to the final point. Its SI unit is also same as that of the distance, which is meter, but it is a vector quantity because it depends on the direction. Then next one, we go to speed and velocity. Okay, speed is defined as distance per unit time. Okay, or speed is defined as the distance covered per unit time, and velocity is displacement per unit time. Okay, both of their SI units are same, that is meter per second and meter per second for speed and velocity respectively. But here speed is a scalar quantity and velocity is a vector quantity. Okay, then we can also have two types for speed as well as velocity. Okay, uniform speed, uniform velocity, or non-uniform speed, non-uniform velocity. So like earlier in the beginning I mentioned about the uniform motion and non-uniform motion. It's just the same as that for speed as well as velocity. Okay, if a body covers equal distance in equal interval of time, then it is called uniform speed or uniform motion, uniform velocity. Okay, the non-uniform speed or velocity will be just the opposite of this one. Okay, without wasting any time, let us go straight to acceleration. Okay, acceleration is the rate of change of velocity. Okay, acceleration is defined as the rate of change of velocity. So we write velocity by time. Okay, the SI unit of acceleration is meter per second inverse 2 or meter per second square. Okay, it is also a vector quantity. Okay, then we have 3 formula to derive, okay, which is of motion. Okay, 3 equations for motion. So we can derive by 2 methods, okay, integration or graphical method. So I will not go much deeper about the derivation. If you need the explanation, I will give you in other videos. So here are the 3 formulas that we have to remember. That is V equals to U plus AT, S equals to UT plus 1 by 2 AT square, and V square is equal to U square plus 2AS. Okay, here V is referred to as final velocity. Okay, U is initial velocity, S is distance, okay, then A is acceleration, T is time. Okay, so V is the final velocity attained by the body, U is the initial, okay, in the beginning what was the velocity of the body, S is the distance, A is acceleration, and T is time. So these are the 3 formulas, okay, of motion that we will be using in the numerical problems in the in this particular chapter. Okay, we have to memorize these 3 formulas as of now. Okay, now like let us check out the SI unit. Okay, V and U are both velocities, so the unit will be meter per second. S is a distance, so it will be meter. Acceleration we got here meter per second square. Okay, and T will be in second. Okay, those are the SI unit of the physical quantities, okay, of this following physical quantities. Now moving on, we next we have circular motion. Okay, circular motion means a motion which is in the circular path. Okay, or maybe we can say in this way, if a body moves in a circular path, then it is said to be circular motion. Okay, so the only condition is the body have to or must move in a circular path, then we can say that it is circular motion. Okay, now for this also we can just form it. Okay, circular motion can be either uniform or non-uniform. For uniform, if a body covers equal distance in equal interval of time in a circular path or along the circular path, then it is said to be uniform. Then non-uniform will be just the opposite. The body must not, okay, cover equal distance, or if a body does not cover equal distance in equal interval of time, then it is called non-uniform circular motion. Okay, then let us try okay, one more thing. For a circular motion, the velocity will be, okay, distance by time. Normally velocity is distance by time, but for a circular motion, the body is moving in a circular path along the boundary of the circle. Okay, so the boundary of the circle is nothing but the circumference of a circle. So the distance covered by the body is equal to 2 pi r by t. Okay, if it completes one revolution or one complete circle, okay, then it will be 2 pi r by t instead of d in case of a circular motion. Okay, so that was all about this chapter 8. Okay, now let us try one numerical. Okay, let us try out one numerical given by this given 3 equations. Okay, so here is the question. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? Okay, so here what we can find out is height. Okay, height is 20 meter. So it will be the distance covered by the body, okay, or by the ball. So distance is equal to 20 meter. Okay, these are the given values. Now if its velocity at the rate of 10 meter per second square, so we have to check out the unit. Okay, it is in 10 meter per second square, so it is a value of acceleration, because acceleration as a unit is meter per second square. That's why acceleration is equal to 10 meter per second square. Okay, 10 meter per second square. Then we are asked to find what will be the velocity if it strikes the ground. When the ball reaches the ground, what will be the velocity? That means we are asked to find final velocity. Okay, and we are also asked to find after what time will it strike. So the time also we have to find. But then you just see, when the body was just gently dropped from a height of 20 meter, initially the ball was at rest. Okay, in the beginning it was at rest, then only it was released. Okay, so it was at rest initially in the beginning. That's why u will be 0 meter per second. Clear? Now we have to find v, we have to find t. So the only formula that we can use is out of these three. Let us check out. V equals u plus at. We are asked to find v, we are asked to find t. So we cannot apply this first formula. Next one, s equals to ut plus 1 by 2 at square. We don't, yes, we can use the second as well as even the third formula. So let us try out with this second formula or anything. Okay, this second one may be a little bit, okay, you can try second one also, but I'll go with the third one. Okay, so v square equals to, okay, we know v square is equal to u square plus 2as. Okay, you see, v square we are asked to find, u we know, 2 is there, 2 is the value, a value we have, and s value also we have. So we can find out v square is equal to u square 0 square plus 2as is 2 into a is 10 into s is 20. Okay, the units I hope you won't find difficulty to understand. So 200 into 400. Okay, so v equals to root over 400 equals to 20 meter per second. Okay, so our v we got 20 meter per second. Okay, then again, now we are asked to find the time. Okay, in what time the ball will strike the ground. So we know again we know that v equals to u plus 80. Okay, you can use the second one. Okay, the second formula, the first formula also, any one of them. Okay, so v we know it is 20, u is 0 plus a is 10 into time is what we are asked to find. So 20 divided by 10 equals to t, isn't it? So 10 is transferred this side, that's why it is gone to denominator. Okay, cut, so t equals to 2 seconds. Okay, t equals to 2 seconds. You can see 20, v is 20, u is 0, a is 10, okay, and t, that is what we have to find. So you transfer the 10 this side, it will be 20 by 10 equals to t. Okay, this 0 is gone. So 0, 0 cancel, 2 is left, 2 by 1, which is 2 only. So therefore t equals to 2 seconds. Okay, so that way we got the final velocity and also the time taken by the ball to strike the ground. Okay, so I think this is a very simple question for class 9. Okay, it is a class 9 level, but also this concept is used even for class 11 as well. So I hope you will be it will be helpful for the class 11 students as well. Obviously this is for class 9, but it will be even helpful for class 11 as well. So thank you very much for watching this video. This is a complete explanation about the chapter 8 with one numerical. I'll be giving out some more numerical problems or solving some more numerical problems in the coming days. So please do not forget to subscribe my channel and do not forget to click the bell icon. Also, do not forget to comment what type of video or what type of numericals, or you can just share me the question and then I'll try to solve out from my side. So thank you very much for watching this video. Thank you.